Okay, so we're looking at the quiz 2 now. The first questions doesn't have any calculations. So business travel demand is generally what? And we know that from our lecture material that business travel demand is generally inelastic. So a fair increase increases total revenue. So the answer to that one is B in that particular. There's two versions of the quiz, but in that version of the quiz. Question 2 is asking you the break-even seat factor on an aircraft is calculated as what? And we know that the break-even seat factor is CASK divided by yield, and your CASK is your cost per ASK, and your yield is your revenue per RPK. So the answer is A, cost per ASK divided by revenue per RPK. And that's question 2. All right, question 3 has got some calculations. So question 3 is a 737 with 170 seats, flies Sydney-Melbourne 706 kilometres with 122 passengers, and then continues on to Cairns, which is 1,967 kilometres with 146 passengers, and we're looking for the total route load factor. So this is a good example of one there where the seat factor for a particular sector is going to be different for the two sectors, and we're after the total route load factor. So it's the load factor for both combined sectors from Melbourne, Sydney, and then Sydney on to Cairns. So we do them separately. So the first one here you can see we've got Melbourne, Sydney, 706 kilometres, 170 seats, and your passengers is 122. So we can calculate our RPKs, being passengers times kilometres. We know that. So RPK equals pax times kilometres, and we know our ASKs equals seats times kilometres. Sorry, it's a bit messy there. So RPKs, pax times kilometres for Melbourne, Sydney, RPKs, pax times kilometres for Sydney, Cairns, and our ASKs are seats times kilometres, and seats times kilometres, and then our load factors divided, RPKs divided by ASKs. And so to get for the total service, so I'll just write that here. So load factor we know equals RPKs on ASKs. And if we sum up the first route, the second route, and then our total sum for RPKs and ASKs, and we get our load factor for the total two sectors combined, or the total route, which is B, 82%. All right, question 4 is looking at block hours. Now, I've had a few questions about block hours, and so block time is defined as when the doors shut, basically to, so the doors shut, you taxi, you take off, you fly, you land, you taxi, you pull up at the gate, and then when the doors open, that's when block time ends. So it's basically everything from when the doors shut to when the doors open at the other end. And that's your block time, and you measure that in block hours. So how many hours is it from when the doors shut to when the doors open at the other end? And the term block, I think I've put a post up for a video which talks about block time or block hours. If you do a search on YouTube, you'll find it. And so it's around the time the door shuts is when they pull the blocks away from the wheels. So there's big blocks that stop the plane from moving. So that's kind of where the name block time came from. So basically what we're asking here in question 4 is it's a 5-hour flight. So we're saying the block hours, it's 5 block hours for the flight. You've got a 767, you've got an A330-200, and you've got a 737-800 with different seats, obviously, and different block hour costs. So that's the cost per block hour. And the question is asking you which one has the lowest cost per ASK. Okay, so what we do, we've got the 3 aircraft types here in question 4, and different seats and different block hour costs. And to get your block hour cost per seat, we simply take your total block hour cost and divide it by the number of seats. So we've got the block hour cost for each aircraft type, we've got the seats for each aircraft type, we divide block hour cost by seats, and the one with the lowest block hour cost per seat is the Boeing 737-800, which comes out at $37.65 per seat. So your answer is C, which is 737-800. And then your last question is an aircraft operates Sydney-Brisbane, 700 kilometres, a daily flight with a 737-800 and a capacity of 5 tonnes of freight. Now, on average, 3 tonnes of freight is utilised, so your actual revenue paid freight is 3 tonnes, and you've got a capacity for 5 tonnes. And it's asking the weekly available freight tonne kilometres, so your AFTKs for the flight. So what we do is we know that our available freight tonne kilometres equals our tonnes times distance, and we know that that's tonnes of capacity. I should make that clear. So it's your available tonnes or potential tonnes times distance. So you've got 5 tonnes of freight capacity and you've got 750 kilometres. So your AFTKs per flight is 5 times 750, which is 3,750 per flight. And we're asked what is the weekly AFTKs for a daily flight. So it's times 7. So if we multiply that by 7, we get AFTKs per week, which is 26,250, and that's answer is D. And that's it.